making Model 2 of the car.
Hi, my name is Daniel Dominguez. I contributed to the team by helping construct the car along with Emmy.
Hi, my name is Emiliano Villagomez, and along with Daniel, I helped create the car and I also helped do the presentation.
Our task was to make a car that travels at least 6 feet and at a constant velocity and a mostly straight path. We researched through trial and error with YouTube.
Alright, so let's begin by looking at the blueprint here. So you can see we began with first of all, we began with a triangular pattern at first. However, we were unable to succeed, so we decided to change the materials to these little wooden sticks, and we were unable to change that and make it work. So we ended up winding up creating something what you see now is this little thing, we found it was going to be the lightest thing you could do. And we also added rubber bands to the wheels, which could help grip. And we also found a lot of problems with the friction being created, so we'll end up solving that. And so basically what you want to do is you want to grab 2 sticks, and then you want to connect them through a straw and put 2 small pieces of straw right here. Run a wooden stick through those straws so it can act as your axles, and then add the bottle caps and then add your strings, and that's pretty much how you make it. It's a very simple, very easy to do process. Anyone can do it at home. You got it.
For our data, we found out that it was mostly consistent on the distance. However, it was very dependent on the amount you wind it up. As you can see right here, we have a winding up mechanism, and this really affects the time and the distance that it goes. But throughout most of our trials, it went about 2 meters, and the time was I would say the average was about 4 seconds, and the average velocity was about 0.5. And then for our analysis, we discovered that what worked well for this was the tension system. However, I thought the wheels were really inconsistent. When we were making it, the wheels kind of were off due to human error, and that resulted in a lot of trials not working. So we had to do a lot of things we had to improve, and that's why we also switched over from the triangular frame to this one.
Alright, so now the big question is, how does this cover AP Physics 1? So what this really shows us is, this is really just a closed system to say, and it's just the transfer of energy, right? We see the energy being transferred from the tension to the string, to the axle, to the wheels, which then turns into the thing moving. So that is a key part of kinematics.
So just like my friend Emmy was saying, kinematics is all about motion, speed, distance, and time. And this is actually a perfect example of it, because it maintains a constant velocity all throughout until friction acts upon it. And that's a lot of what we learned throughout this entire thing. The transfer of velocity and forces.
And yeah, that's going to be all for today. Thank you for watching.